Okay, so basically I will start with some background and then go to the more technical part. So because I think everyone has really different backgrounds. Some of you may be really familiar with all these backgrounds. So bear with me, and I'm not assuming any backgrounds in AI agents or MCP. So basically, we know LLM works like a chatbot, right? So you send a message, LLM give you back message, and then back and forth. That's the basic way of interaction. And then actually up to today, all these more advanced way of using the language model, like you let the model use tools and so on, these are actually still in the same way. You're just sending it some text. So for example, like if you go to our website like TXYZ, then you chat with the model not only hear what you say, but also see the context of the paper. Then that's an example of a context. And so you have the paper as the context, the model answer your question. But that's basically just another part of the text the model receives. And then the tool used, like you heard from Joanna's talk. So the AI needs to write code or use other tools. But these tools, what is the AI actually doing when it uses these tools? It's just seeing another part of the text from. It's just seeing that maybe it's very guidance. So these tools that the AI use is also through the text from. Right? So you tell the AI what are the inputs of the tool and what you so expect as the output, the meaning of these tools. So these are the information you put in the text of prompt, and then the AI is supposed to give you back these outputs, and and of course these models are specially trained for using tools. But but fundamentally, it's basically also using this tool as a context, and that's why this protocol we're talking about here is called the model context protocol, because everything for the model is the context. So talking about scientific research, we have each of us have different research fields, and we all have very different research tools. So if I roughly speaking, if I classify the research tools, we have different kind of tools like computational method, like all the simulation, all these like molecular simulation or dense functional theory computation in the material science, all these different kind of tools, which may require a lot of skills. And then there are environmental equipment, and there are wet labs which you need to control by your hand, and that will be more difficult to connect to AI unless you have. Oh, sorry. I didn't turn on the microphone. Thank you guys. Um, sorry. I guess I didn't turn on the microphone, so maybe you didn't. Maybe nobody can hear me in the recording. So yeah, so we just started to talk about the MCP. The previous part was about what are the scientific tools, and then the AI has everything as a context. Okay, so we have all these different tools in scientific research, and what MCP, this model context protocol developed by Anthropic, what it is basically a USB connector between agent and tools, right? So before having MCP, last year when we work on this direction, if you want to connect AI to some, for example, your simulation method, then you have to write the whole thing. You write the code that let the AI agent make the tool use, call that, and then get back the results and so on. You have to write the whole code. And then now with the AI, it's now with the MCP, it is easier because we make this universal connector. So there is this universal connector between the tools and the client, and so like people like experts who knows how to use these tools can focus on building the right side, and focus on building the MCP servers which contain all these tools. I'm just using some trivial examples, like one tool may be doing multiplication, the other is doing some other algorithms. So you have all these different tools, and you don't need to worry about building AI. And then the AI agents like Cloud and GPT and everything, focus on the left part and just make sure it's connected to the USB, right? And then now, as long as you write your code in this form, which is called MCP server, and then the AI companies write their code in the form of MCP client, then you can connect between them, and that makes it much easier for many more people to contribute to building AI agents. So we can say a few words about what AI can do in scientific research, which is, as we discussed, we heard earlier, right? It's possible that we could automate a lot of tasks. But it could also reduce a lot of communication barriers. Right? Think about like your research tool that you manage to use it very well in 3 years, 1 year, or 2 years, or any time. That a lot of these things requires a lot of expertise. And then if you try to like write a very long manual to teach someone else to use that tool, even if neighboring field, it will be really difficult. So now if you teach the AI agent to use the tool, then people who even don't have any expertise in your field can learn from your expertise, can directly use your expertise to do more research. Right? So say if one of you build this AI tool tomorrow that's doing biology research, and if I have no idea about it, I can still like use an AI agent, ask the agent to explain to me what this tool is doing, ask it to do the work. So and then that it will be possible to start many more collaborations there. So I'm speaking as founder of this Pathogenic Neural Institute, and you have received our also the other part of the effort was building this AI agent specialized for AI, specialized for scientific research, which is Lucian that you received in the link. Try to install it if you haven't. So this diagram is just to explain the general theme that we have all these different open source platforms that's part of the Pathogenic Neural Institute that will stay open. It's basically like archive but for the modern time. And so you have MCP.science, which is this open platform for everyone to contribute their research tools in the form of MCP server. So after the hackathon, if you have these new research tools connected to AI, we will really welcome if you contribute that to the MCP.science. So we want this to be the place where scientists can come here and find all different kind of tools and easily, like one click, connect them to AI, not only to our agent, but to all other agents supporting MCP. And then we have other platforms, Bench.science, which is doing the job of evaluation. It's also an open platform. Anyone, if you want to build a benchmark set for your field, you can start a team here and contact us and start a team on Bench.science, and then you can collaborate there. And then there is MCPM, which is a tool for enhancing the MCP protocol, give it more convenience for you to connect the server with the AI agent in the command line. So and then all the different AI agents can use these research tools, and the Lucian is the agent we develop, which we hope to make it convenient for scientific research tasks. Okay, so that's the general picture here. And then if you contribute to the MCP.science, later we're going to discuss in more detail here, like when you contribute to MCP.science, it's really convenient. Anyone can use your MCP server like in one command line. You can put in that command and anyone can use this server. So this is the advantage that it may become a hub of not only the servers we developed, you developed, but also like we can connect in all other servers related to science. So that's the part about the general things. If you have any questions, please feel free to let me know anytime. Any questions so far? Okay, if not, let's go to the more technical part. So like, again, this is like a beginner's guide. So if you're already familiar with MCP, you may not need this part. But for those of you who haven't developed with MCP, so the way of connecting your research tool to the AI is basically these steps. So you set up the environment, which means like what Python, what and what version of these things. Right? You set up the environment, and then you just start writing your code based on what you have in your research already. Right? Say you have some code that's operating your experiments, then you're just wrapping that in a simple way to develop MCP servers. Right? So if you have some computational function, you can just wrap that. And then after that, you connect it to the MCP clients, and then you can contribute to the open source repo if you like. So that's the 4 steps. the first step is, so I mean, this is not the only way, but we provide one way that's like very explicit and simple, right? So you can install this thing called UV, and then after you install the UV, you can use it to manage all these dependencies, and then so you can follow these commands written here. It's also in the more detailed guide. So if you click the link, you can see more details. Here, I'm just this tutorial is to like adding some like just the highlights, right? To walk you through the key steps. But then if there's something confusing, you can go to the more detailed guide. Right, so basically, once you have UV, you go to the folder where you want to put your MCP server, where you create a local folder, and then you start to init and then set the virtual environment, and then you add MCP. Right, so once you add MCP, you can start writing. And then here is the central part. Do let me know if there's anything confusing. Right? Yeah, so then the central part of building MCP server is I mean, it doesn't have to be in Python code, but just to be concrete, all our instructions are in Python. There are other ways, but our instruction actually only covered the case with Python code. So with Python code, it basically is like this, right? So like, let's say you have a function that's part of your research, right? Of course, I'm using a really trivial example. I'm just adding two numbers, but it could be a really complicated computation that runs for an hour, right? Something like that. So then for any function that's your starting point, if you want to convert that into an MCP server, you need to do several things. Right? You first make sure there are type hints. Like you can tell the AI that this is an integer, this parameter is an integer, that parameter is a float, or that parameter is a list of integers. Right? So you need to specify all the types of the inputs, and then you add a doc string. And this is what the AI see. The AI will not see the code, because the code could be super long, right? The AI does not need to see the code, but the AI will see this doc string, which is in this triple quotation marks. The doc string tells the AI this function is to do this, right? You can add any description here, like this function is useful because I needed to process my data, right? So any, of course, it's mainly the instruction that's useful for the AI, but you can put anything here, and then you can specify the arguments and the returns. I mean, the types the AI already know, but you can probably add some explanations of the meaning of the variables, and that could be useful. And then the third thing you do is, okay, you just start to build this server. You import this from the MCP, right? You import this fast MCP library from MCP server fast MCP. Just a reminder that there's some confusion. There's some other library called fast MCP, so make sure you follow this one. And then you just need to specify the types of inputs, because the returns that the model can read is kind of restricted. So you specify, like it's a text or image. It could be something more general called a blob resource contents, which could put in anything, but of course the model may or may not understand it. Right, so this is how you wrap a function, right? So you start with a function you already have, you add this decorator, you import the MCP and you add this decorator. You add this decorator like at MCP thing, and then that's it. And then with that, then the model could now use this, and you need to add this entry point to let the model know this it could run this function, and that's it. That's so I will have some more tips about more details, but this is basically the key steps of defining an MCP server. Once you define MCP server in this way, the AI can see, the AI can use we're going to show later how you connect the server to the client. Basically, you need to tell the AI what command you use to run the server and what's the path, right? Where is the server? And once you tell it that, then the AI can start using this server and like do what you do with the function. So say your function is doing a simulation. Now the AI could do the simulation, and then this function tells the AI what's the output. Any questions? Okay. Okay, so just a few tips of building the server, because like we use a really simple example, but if you really want the AI to see an image, especially for multimodal models, you want the AI to see an image, then you need to make sure you return it in the space64 format. So it's just a bunch of strings. And so there is an example here in one of the servers on mcp.science where we show how to actually like convert these encode this into the base 64. Another tip is there's something called subprocess, which means you can, in Python, you can run a subprocess and that can run any command. Like anything you can use in your command line, like list some files or run another app, like run Mathematica, right? Run whatever other app. You can do anything you can do in command line, you can do through subprocess. There are subtleties like you need to make sure you are running the command from the right place and so on. But I'm mentioning this because this is a general way that you can connect your MCP server with something else that's not in your Python code. Right? If something is already in your Python code, you just convert that by adding these tags. But if it's something totally different software, right, you can still run it by using a command. And this can make it really general. And the other thing I want to mention is that, like, be aware that you don't want to, like, say your function may be returning a really big file, right? So you are doing a computation, the output is a really big file. The model doesn't necessarily need to see that, even if it sees it, even if it doesn't, it could exceed its token window, or it doesn't make sense to let the model see a million numbers. So instead of that, probably you would want to, like, save the file somewhere, return a path or return an ID, and then just in what the model see, you just give it a text description. Say this calculation has been done. Here is the path. So here is the ID. That's just one of the simpler ways. Like, be aware like what you want the model to see. Right. So you can take your research tool, and then maybe some part of the result will be needed for some other function you use later. Then you can either return that to the model, or if it's too big, you can save it and return the ID to the model. So here I'm just giving some examples of that. You don't have to follow exactly that format. It's just a reminder that for those of you who are not familiar with UUID, that's a way to generate a universal, like a unique identifier, right? So then you never need to worry that it's going to be like redundant or repeated by another one. Yeah, so that's the part about building the MCP server. Like how do you convert your code into MCP server? And once you have the MCP server, then you can locally test it. Again, these are all on the instructions on mcp.science. You can see on the lower right corner. Then you can test the run, and then you can also, there is also this built-in develop tool. Like previously we have installed MCP. So if you're in the command line, if you say, you go to your server folder and you say MCP dev main.py, then it will give you this dev tool, which means you can like click connect, and then there are these tools, and you can put in the input, and then it will give you the output just to show this tool works. So like instead of letting the model call the tool, you are just manually call these tools to check it works. And then after that, you can connect the MCP server to AI agents, and then discuss about contributing to mcp.science. Chen Chen is the CEO of Path Integral Technology, and he's also like behind the whole all the technical development of Lucian. So
yeah, I'm just gonna quickly run through, I guess, high-level instructions on how to maybe let me start with a high-level concept of transport, two types of transport for MCP server. So the first one is called streamable HTTP, and in the past it's also referred to as SSE, but that has been deprecated. But basically, like anything, when you see an MCP connection instruction that asks you to provide a URL, it's basically using this streamable HTTP, and it's best suited for accessing a remote resource, like something you host in the cloud, for example, your Gmail, or maybe like your Google Calendar, or I don't know, like a Dropbox account or something. And then the other type, which is the one that we will be focusing on today, is the standard IO, SDDIO. It basically like starts MCP servers as a local process, and it has the capability of accessing all of your local resources. So imagining you have a lab equipment that are connected to your local computer, or if you want to access a compute cluster that is only accessible through your private network within the university or your research lab, or something like a file or piece of data or code that you want to run locally. So all these are best suited for the standard IO type of transport. And yeah, it also it's less complexity to build and very minimal work to maintain. So we recommend like trying controlling MCP servers with Lucian, which is the scientific research agent app that we built. So every one of you should be added to the allow list already. Right now, it's still in the invitation only testing phase. We're still quickly like prototyping and iterating things, but feel free to report any bug or issue you see. But it's provided to all of you for free, and there's no token limit, so feel free to explore. And it also has functionalities of connecting to Jupyter Lab and doing work in Jupyter Notebook and running code and doing analysis. So feel free to give it a try. The other option is you can try this app, open source app called Fire, and you can apply for your $400 Lambda credits, which is a cloud inference service, and they provide this Llama 4 model, which is multi-model and has function calling capabilities. So you can connect it with MCP servers through this open source Fire, and instructions are provided again in the documentations on the bottom right link. And the third way is that you can also try Cloud Desktop app. Cloud is built by Anthropic, and it's the company who initiated the MCP protocol. So that's another option. They have a free tier, which comes with token rate limits, but it also works with MCP nicely. And yeah, while you're developing these standard IO MCP servers locally, do remember to add this last environment variable when you're setting up the MCP connection, which basically tells UV to look into this directory for dependencies that it needs to install. Yeah, if you run into issues, we also have on-site technical support team here, so just raise your hand if you need help. And the last part I want to cover is how to contribute to MCP science. As Professor Chi mentioned, that this is an open source repo for all MCP servers that are related to scientific research. So we love any contributions. So basic steps: you can fork MCP science repo on GitHub, and then you can clone the repo to your local computer. And you can then make your modification, add your server under the servers directory and create another PR to contribute it back to mcp.science. And once you do that, once you create the PR, your MCP server can be easily started from like any MCP client that supports standard IO transport by this simple command, just with the extra -b, with the branch name of your PR at the end, so you don't have to do any other thing to host it or make it accessible to other people. That's the only thing you need. And once the PR is finally merged, it can be started by simply entering this command UVX MCP science followed by your server name. And then yeah, the last thing is also if you are brave and want to try vibe coding and coding together with a coding agent, you can give this Jules a try. We've used it to build multiple MCP servers on MCP science, and it's free, and feel free to give it a try. It works nicely with the GitHub development flow. And yeah, I think that's everything I want to cover. And if you run into any question, you can always raise your hand and ask for help.
Okay, thanks, Chen. Yeah, so the contribution to GitHub part, I mean, those of you who are familiar, you can start with there and then like put your server directly already in this forked repo. That will be like really convenient. But if you are not familiar, you just want to start working on your local server, that's also totally fine. Right? You can skip that and just create a local folder, do everything local, and worry about how to build the GitHub later. Okay, so that's all. And then this is the resource, and you can find any more detailed instructions here. And another thanks to our sponsors, Lambda and the Xiao-Liang Foundation. Thanks. Okay, so now let's start hacking. Let us know if you have any question.